Okay, so I'm doing this live and, just on the spot decided in the moment to carpe diem. Okay, and where is my markers? This happens every time. Didn't I just have the blue? Oh my God, there it is. Lord Jesus. Okay, is everything good in my center? Is everything fine?
Yes.
Okay, thank you. So, yes, bell work review. In a nutshell, we have to make sure that we are absolutely clear about determining, what we see isn't a function, okay? So, okay, like we discussed on yesterday or whenever I saw you, okay? We have a table, we have mapping, we have an equation, we have a graph, and we have a list of ordered pairs. And the question is going to be, is this a function? 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 Now, here's the thing, folks, okay? And students don't make the connection that all 5 of these mean exactly the same thing. They're just presented in a different way. Now, the secret key that we discussed, okay, and this goes for the table, mapping, and the list of ordered pairs, okay? In order to tell if a relation, a list of ordered pairs, which is in a list right here, which is in the table, which means the same thing, which is in the mapping. The way that you can tell a list of ordered pairs is a function. The secret key was that the x values, okay, do not repeat, okay? That was the secret key. So if you look at the table, we have -2, 0, +2. None of those x values repeat, so check, that is a function. Let's look at this list of ordered pairs. Circle the x values. Circle the x values, aka also known as the what? The domain. The domain and range. Domain is x values. Your y value is the range, okay? These x values, x, y, x, y, x, y. Your x values, that's a -2, 0, +2. They do not repeat, so check. That is a function. Okay, now look at the mapping. We're looking pretty good so far, okay, because we have -2, 0, +2, right? So we're thinking, oh, that doesn't repeat. Check, that's a function, which this case, it is the case true, because this -2 is paired with this +1, this 0 is paired with this -1, and this +2 is paired with this +1. Here's the thing though, pretend, okay, everybody put the star, because with the mapping, it's easy to do with the table, the x values do not repeat. It's easy to do it with the list of ordered pairs because the x values do not repeat. And we can see here that we have -2, 0, and +2, which looks like, which is the case that the x values do not repeat based on the way that the arrows are pointing. But what I want to make absolutely clear is this. Pretend, okay, you had, the number 3, pretending, okay, and over here we had a -2. Just pretend, okay? And this +3 had an arrow that pointed to the -1, and the +3 pointed also to the -2. Pretending, okay? When you see that, okay, folks, what that is saying in the mapping, this is only for mapping, okay, it still looks like, look, -2, 0, +2, +3. It still looks like none of those x values repeat if you're just looking at the left side. However, because this +3 has an arrow that's pointing to the -1, and because this +3 is pointing to the y value that is a -2, that means this x value of a +3 was used what? Twice, okay? Which means that that x value is repeated because it's used twice, because the arrow is pointing to the -1, and it's a second time it's pointing to the -2. So when you see that, no, it is not a function, because one of those x values is pointing to 2 different numbers in the range, which means that that x value is being used twice. Does that make sense? Okay, so in that case, it would be a no, This is not a function. So when you're looking at, you know, the x values in the mapping, it is true that the x values should not repeat, but it's what the arrows are pointing to with the mapping that tells you whether or not the x values repeat. Does that make sense, you guys? Okay, I just wanted to clarify that for you. Now, equation. We know, okay, reviewing, that this f of x, the function of x, means the same thing as y. And we said 1/2 x squared minus 1. Now, you know, also, you know, y equals mx plus b. Okay, here we go. Okay, the equation of a line. The way that you can tell, so for the list of ordered pairs, the table, and the mapping, we said that the way that you could tell for these three examples, okay, if they were a function, is if the x values do not repeat. Okay, now with an equation, the way that you can tell if an equation is a function is if the y and x variable, okay, circle it, okay, if the x and the y variable are present in the equation, okay, you can't just have like x equals 2, okay, that is not a function. In the equation, in order for an equation to be a function, the x and the y variable must be present. Now, I'm going to say that this f of x counts as y. Why? Because f of x, the function of x, means exactly the same thing as y. Okay, does that make sense? Moving on. Here we go, graph. Now, so now you know how to tell if the table, the mapping, and the list of ordered pairs is a function. Now you know how to tell if an equation is a function. And now finally, the last part is the way that you can tell that a graph is a function is a different way. We use the vertical line test, okay? So just to point it out to you every step along the way, you guys, and some students, even though I went over this on yesterday, some students did not get it, okay? They just did not understand. I'm trying to make it as, you know, symmetrical as possible. That's the best I can do on the spot, okay? Each one of these points on this quadratic parabola has a different x value. This has an x and y value, this has an x and y value, this has an x and y value. None of these x values repeat as we read graphs from left to right, as we go across our merry way. Okay, none of those x values repeat. Does that make sense? So therefore, yes, that is a function. Okay, so that is our bell work review. Okay, and onward to the next video.